Statistics, Modeling, and Finance, Chapter 4, Inferential Statistics, page 11. T-table continued. Now we have our mean of $161,417 and our standard deviation of $9,984. Let's look at the T-table. Remember how we mentioned degrees of freedom? Every time we do a calculation, we lose 1 degree of freedom from the sample. Our sample on the previous page consisted of 12 cells, so we will look under 11 degrees of freedom. The T-table is so large that one goes up to 100 degrees of freedom that I will just display part of it on the screen here. The degrees of freedom range down the left column. The column headings to the right refer to the confidence interval. For example, the first column to the right is headed 0.10. This represents 100% minus 10%, or the number of standard deviations that it would take to include 90% of the observations. The second column, 0.05, is the 95% column. The third column, 0.025, is the 97.5% confidence column. And the last one to the right, 0.01, is the one to use for 99% confidence. Note, there are T-tables that have been constructed with many more columns so that you can find figures for more intervals such as 30%, 25%, 20%, etc. I have included just 4 columns for simplicity's sake. Look at the table above and go down to 11 degrees of freedom in the left column. Then, as you go across the row to the right, you will see the numbers under the 4 columns. These represent the number of standard deviations you would have to go out, both above and below the mean, to achieve those confidence intervals. For example, with only 12 in the sample and 11 degrees of freedom, we would have to encompass 2.2010 standard deviations to achieve 95% confidence in the results. Not the 2.0 that we generally espouse with a full normal distribution. For 99% confidence with 11 degrees of freedom, we would have to include 3.1058 standard deviations instead of 3.0. What does that mean? Let's take the 95% confidence level. We would have to go out 2.2 standard deviations to ensure that level of confidence. Our mean was $161,417. And our standard deviation was $9,984. $161,417 minus 2.2 multiplied by $9,984 equals $139,452. $161,417 plus 2.2 multiplied by $9,984 equals $183,382. We could have confidence that 95% of the observations would fall between $139,452 and $183,302, given that sample of 12 cells. By the way, what if we only had a sample of 3 and we wanted a 95% confidence interval? Look above and you'll see the figure for 2 degrees of freedom is 4.3027. That is one heck of a range. That's why we don't use this procedure with only 3 comparable cells. End of page.